Okay, so Friday we talked a little bit about inverse trig functions. Okay? And we kind of looked at the graph of inverse trig functions, what they would look like. And we kind of talked about what we could do to make it a function, if you will. Because if you recall, they don't pass the vertical line test. Okay, remember the graphs from Friday that didn't pass the vertical line test, so therefore they're not a function. And kind of how we would restrict that a little bit, okay, to make it a function, so it could pass the vertical line test. So anyway, I'm kind of going to build on that a little bit. But first of all, to refresh your memory, okay, if I have y equals sine x, all right, what is the inverse of y equals sine x? Y equals sine inverse x, sine with a little -1, right? Okay, so the inverse of that was y equals the inverse sine of x. Okay? Another way you'll see it written is this. Y equals arc sine x. They're the same thing. Okay? Why the different notation for it, I'm not really sure. I just know a lot of textbooks have done it both ways. They mean the same thing. Okay, yes?
I think the reason they use arc sine is if you just use like inverse sine, people will think of, sometimes people think of it just like 1 over sine, and usually that's, I mean that's basically what it is, but usually people just want to use arc sine because it's less confusing.
They won't get confused with a multiplicative inverse or something like that? Sure. Yep. Okay. Could very well be the case. So anyway, you'll see both sets of notation. Understand they're both asking you to do the inverse sign. Okay. Keep in mind, what do inverses help you find?
What x here y equals?
What y equals, and y in this case is always an angle. Okay. It's like the reverse of our time test. If I say the inverse sine of 1/2, what am I really asking you to find?
30 degrees.
30 degree.
But when I say inverse sine of 1/2, what am I? Yes, the answer is one of the answers is 30 degrees. But what am I asking you to find?
The angle.
The angle whose sine value is 1/2. When you see inverse sine 1/2, all right. When you see this, I'm asking you to find the angle whose sine value is equal to 1/2. Okay? So inverse sine or arc sine is asking you to find an angle. Different than your time test, right? In your time test, I just ask you, hey, what is the sine of 2 pi over 3? 2 pi over 3 is your angle. I ask you to find the value. Find the value of sine of 2 pi over 3. This is the inverse of that. It's undoing it, okay? It's asking you to find the angle. I'm giving you the answer, you find the angle, all right? So that's kind of what we're working with here a little bit. Now, if I would ask you to evaluate, and we'll continue to use that 1/2 one here. If I would ask you to evaluate the inverse sine of 1/2, I've already heard one of your answers, well, somebody just went 30 degrees, but in radians, what would that be? Pi over 6. Is that the only answer? No, there's a whole bunch of them, okay? And then really, if you wanted to write every possible answer, you'd have to write pi over 6 plus 2 pi k, where k is an integer, okay? Because, you know, pi over 6 is like 30 degrees, right? If you go around the circle one more time to get to 390 degrees, or whatever that is, 13 pi over 6, you could keep going around the circle one whole time, go around again, okay, and you'd get to those infinite number of answers, okay? What would be the other set of answers? Where else is the sine of some angle 1/2? What quadrant would that be in?
Second.
Second quadrant, what's the 30-degree angle in the second quadrant?
150.
150, what is that in radians?
5 pi over 6.
5 pi over 6. So you could say 5 pi over 6 plus 2 pi k. All right? If you had to find every possible answer, this is the way you would have to do it. It's kind of a pain. Okay? And also, remember, this is not a function. Okay, this is not a function. It's the graph that, did the wave all the way up. And that's why there's an infinite number of answers, because if you wanted to go every place where the sine value is equal to 1/2, there would be an infinite number of them, both going up in the positive direction and going down in the negative direction. Okay? So, in order for you to get a single answer, or to know what your calculator is going to give you, they created what's called the principal values for all of these. And they start capitalizing them, and that's when you know just to use the principal values. Alright? So, if you see this, or you see this, if you see those capital letters, they only want answers, okay, between negative pi over 2 and positive pi over 2. And that's what your calculator would give you. It's like saying they only want answers from negative 90 degrees to positive 90 degrees when you see those capital letters. Okay. For instance, if I would ask you what's the inverse sine with a capital S of 1/2, if I would ask you for the inverse sine of 1/2, what would the answer be using these principal values or using the capital letters? Pi over 6, or in degrees, 30 degrees. That's why on your calculator, if you're in degree mode and you type in inverse sine of 1/2, the calculator only gives you the answer 30 degrees. That's it. Because the calculator is not going to give you an infinite number of answers. It couldn't run that program. It couldn't run that calculation. Okay, so it only gives you answers between negative 90 and positive 90, or between negative pi over 2 and positive pi over 2. Okay? Same thing for tangent. They also use that same restricted kind of domain or range there. Okay? All the answers your calculator is going to give you are between negative 90 and positive 90, or if you're in degree mode or radian mode, okay, they're going to give you answers between negative pi over 2 and positive pi over 2.
Do we need to be in a certain mode? Like, does it matter what mode we're in?
Well, it probably honestly depends how well you know your trig values. Okay? If you're going to use your calculator a lot, you'll probably want to be in degree mode, but you might have to convert your answer then back to radians. If I ask you what is the inverse tangent, capital T, inverse tangent or arctangent of negative root 3, okay, if you have trouble coming up with that answer mentally based on your trig values, put your calculator in degree mode and type in inverse tangent of negative root 3. The calculator will give you negative 60 for your answer. Because what angle has a tangent of negative root 3 between here and here? Well, it'd have to be a 60-degree angle. It's obviously not the one in the first quadrant because tangent is positive in the first quadrant. So it's got to be the 60-degree angle in the second quadrant. But don't write 300 for your answer, guys. Okay, everybody hearing me on that? 300 degrees or 5 pi over 3 is not acceptable for that.
So cosine would only be the one with 2 possible answers.
No, because now that was where I'm going next here, but you kind of follow me?
Yeah.
You might want to be in degrees to get your answer, and then if they want the answer in radians or whatever, okay, then you can change it back. Okay? Notice, this is using like the fourth quadrant and the first quadrant, right? That's okay because in the fourth quadrant, sine is negative, and in the first quadrant, sine is positive. So we cover all the negative and positive possibilities. Same with tangent. In the fourth quadrant and the first quadrant, we cover all the negatives and the positive possibilities. The problem with cosine then, if we only use the fourth quadrant and the first quadrant, we could only get positive values. You could never do the inverse cosine of negative 1/2. So cosine has a different set of values where the answer is going to be, and it's going to be in quadrants 1 and 2. Okay? So for cosine, for inverse cosine, okay, all of your answers are going to be between 0 and 180 degrees, or between 0 and pi. Because we got to be able to hit all the possible positive and negative answers. Now, I know on Friday we worked a little bit with the graphs of these. You will not actually, on any of our exams, have to graph any of these inverse ones, but I thought it would be good to show you those so you kind of had an understanding of what they are. All right? So for the other class that's watching the video here today, they didn't do what we did on Friday. They're going to be fine. This is what I'm about to do next is the stuff that you'll have to do on your test. Okay? So if you want to follow along, you can. I'm going to be on page 408. And I want to do kind of the type of problems that you're going to see. Okay? So number 1 says arc sine of negative root 2 over 2. Okay, we'll start fairly simple here. Now, when you see this, what is it asking you to find?
The angle.
The angle whose sine value
is negative root 2
is negative root 2 over 2, and that angle has to be between where and where?
Negative 90 and positive.
Negative 90 and positive 90, or negative pi over 2 and positive pi over 2. Okay? We're going to go ahead and use radians here for right now, so we'll get our answers between negative pi over 2 and positive pi over 2. Okay? Now, if you know your trig values pretty well, this is going to be easy. What type of angle has a sine value of root 2 over 2? 45s. It's got to be a negative root 2 over 2, so that means our angle is going to be in what quadrant? Fourth quadrant. So I need an angle down there in the fourth quadrant with a 45, but again, I'm not going around the circle. I am just going negative 45 degrees. So the answer to this is essentially negative 45 degrees, and that's what your calculator will give you. If you would type in inverse sine of negative root 2 over 2 and you're in degree mode, that's what your calculator is going to give you, but we want our answer in radians, so what will our answer be? Negative pi over 4. Yep, because the 45s are over 4, right? Okay, so negative pi over 4. And there's going to be your answer. Okay? Hey guys, are we good? Alright, negative pi over 4. I'll give you another one that's very similar to that. Let's go arctangent of negative root 3 over 3. Arctangent of negative root 3 over 3. See if you can get those two answers. Check with the neighbors. Just for time purposes on the video, I'm going to talk through it here. Okay. Arctangent of negative root 3 over 3. Well, what angle has a tangent value of root 3 over 3? That'd be a 30. It's got to be a negative, so that's going to put me in the fourth quadrant. So my answer simply is negative 30 degrees, which when you change to radians is negative pi over 6. or cosine of negative root 3 over 2, I think. When is the cosine equal to a root 3 over 2? That'd be a 30-degree angle again. When is cosine negative? And remember, my answer's got to be between 0 and 180 for cosine.
So,
So it'd be a 30-degree angle in the second quadrant, or also known as 150 degrees. So on your calculator, you get 150 degrees, but you change that to radians and you get 5 pi over 6. So those would be your two answers.
Is it negative or?
No, no. All of your answers for cosine, inverse cosine, are going to fall somewhere between 0 and pi. So those will be positive, okay? All your answers for inverse sine and tangent could be anywhere from negative pi over 2 all the way to positive pi over 2. So you could get some negative, some positive angle answers, okay? All right?
so
Yeah.
instead of pi over 6, can we put like 11 pi over 6?
No, no.
Yeah.
All answers, I'm glad you said that, okay? All answers to these ones with capital letters like this are going to fall in those ranges right there.
What if it
Always,
doesn't have
always,
capital
always.
letters?
What's that?
What do you do if it doesn't have?
If it doesn't have capital letters, you would have to write that plus 2 pi k stuff, because if it doesn't have capital letters, it's representing every possible solution. Yours are going to have capital letters. Okay? But, got that, Derek?
Yeah.
Always put your answers between those values. Okay?
Some will only have one answer.
Yep. Yeah, because I don't want to grade all of them either. Alright, now really kind of making you think here. So we got the inverse sine of the cosine pi over 2. Okay? When you see a problem like this, do the parentheses first. Always do your order of operations, okay? Cosine of pi over 2. Well, what is the cosine of pi over 2? 0. So really, what we're doing is we're doing the inverse sine of 0. Okay? Do what the parentheses tell you to do first. This is equal to 0. Alright? The cosine of 90 degrees, the cosine of 90 is 0. Okay? So the cosine of pi over 2 is 0. So really I'm just doing the inverse sine of 0. Now, what is this asking me to find again? I'm trying to stress this. This is asking me to find what? The angle whose sine value is 0. Tell me the angle whose sine value is 0. And remember now, this has to be between negative 90 and positive 90. So what angle has a sine value of 0?
Is there 2?
0.
No.
There's just one answer, and it is
Oh, it's y, yes.
0. The only angle between negative 90 and positive 90 that has a sine value of 0 is 0 itself. Okay? Another one.
What if it was like 1? Would there be 2?
There would have been 2, yeah.
Need to state both of them probably.
Yeah.
But he's gonna be nice and measure the help.
Yeah, I do think probably officially I might have to change those, one of those to not include. You won't get 2 answers, let's just put it that way. Okay. If I would see a problem like this, I would probably work with degrees. It'll make it a lot easier on you. Again, work inside the parentheses first. This says the inverse tangent of 1. What is that asking you to find?
What angle?
What angle? Its tangent value is 1. Okay? What angle has a tangent value of 1? That's what that's saying. What angle does have a tangent value of 1? 45. Okay? So really you got 45 right here. Okay? What angle has a sine value of 1?
90.
90, pi over 2, but you'll see why I'm doing degrees right now, okay? Yes, this was pi over 4, yes, this was pi over 2, but do you guys want to subtract 45 minus 90, or would you rather subtract pi over 4 minus pi over 2? Most people would probably rather do this, though. Yeah, it's not overly difficult, okay? But most people would probably rather take 45 minus 90 than pi over 4 minus pi over 2, okay? Doesn't matter, you can do it either way, okay? Most people would probably want to do that. Does everybody see how we got these answers? What is 45 minus 90? Negative 45. So really, what I'm doing is the sine of negative 45 degrees. And that's hopefully one that you all know. Negative root 2 over 2. It's a 45-degree angle in the fourth quadrant, so it'd be a root 2 over 2, but it'd be a negative root 2 over 2. So that's why a little bit, I don't want to tell you only use degrees, only use radians, when you're working these out. Here, I would have rather have done this one using degrees. It's a lot easier. If the answer does ask for an angle, though, like this one, this answer ends up not being an angle. This one actually ends up being a value because you're taking the sine of some angle. All right? So really, you didn't have to work with radians at all in this one if you didn't want to. Okay? I'll do one more with you. It's d there, so cosine, inverse cosine, negative root 2 over 2, minus pi over 2.
Hopefully we can tell. I gotta switch that chair.
Inverse cosine of negative root 2 over 2, what would that be? 135 or 3 pi over 4. Okay? Two ways to do this. If you want to use degrees, totally fine. This is saying 135 degrees.
Wait, why isn't it 45?
Because it's negative. A 45-degree angle has a cosine value of a positive root 2 over 2. We're looking for the cosine, or the angle whose cosine value is a negative, and that doesn't happen in the first quadrant. You're right, it's a 45, but it's got to be a 45-degree angle in the second quadrant. Okay? So this is 135, but if you change this to 135, what do you got to change this to back here? 90. Okay, if you're going to use degrees, and you want this to be a 135-degree angle, then you got to change that to a 90-degree angle and take 135 minus 90 degrees. If you keep it in radians, Jake said 3 pi over 4, and you can take 3 pi over 4 minus pi over 2 and subtract those values. I don't care. Okay? 135 minus 90 is probably what a lot of you are going to do. 135 minus 90 is 45. And final answer, what's the cosine of a 45-degree angle? Positive root 2 over 2. Okay? Alright, on page 411, on page 411 we're looking at problems 22 through 31. Those are the types of problems we would expect you to be able to do on a test. You are welcome to use your calculator on them. I don't think you have to use your calculator on any of them, to be honest, but to just verify your answer might not be a bad idea.